Hey everyone, welcome back to the channel. Today, we are going to explore something truly exciting, neuromorphic computing. It sounds complicated, but don't worry, I'll explain it in simple words. So, let's get started. 1. What is neuromorphic computing? Neuromorphic computing is a special type of computing that tries to work like the human brain. Instead of processing things step by step, like traditional computers, neuromorphic systems process information the way our brain does, quickly, efficiently, and in parallel. Imagine a computer that can think and learn just like us. 2. How does it work? Our brain is made up of billions of neurons connected by synapses. Neurons send tiny electrical signals to communicate. Neuromorphic chips do something similar. They have artificial neurons that send electronic signals, or spikes, to each other, just like our brain's neurons. These spikes help the system make decisions, learn, and adapt in real time. 3. The magic behind neuromorphic computing. Traditional computers do tasks one by one, which can be slow and use a lot of power. Neuromorphic systems are different, they use parallel and event-based processing. This means they react to things only when something happens, not all the time. And that makes them fast and super energy efficient. 4. Where can we use it? Neuromorphic computing is already making a difference in robotics, helping robots make quick decisions and learn from their surroundings. Healthcare, creating brain-machine connections for prosthetics or monitoring brain activity. Self-driving cars and drones, so they can react instantly to changes around them. AI and smart devices, making them smarter, faster, and less power-hungry. In the future, it could even help restore damaged brain functions. 5. Cool neuromorphic chips. Some companies are already building amazing neuromorphic chips. IBM's True North has 1 million neurons and can process tons of data at once. Intel's Loihi can learn and adapt like a brain. And there are others, like Spinnaker and Brain Scales, designed for super fast learning and decision making. 6. Why is it so special? Energy efficient, uses much less power than regular computers. Real-time processing, handles sound, images, and other sensory data super fast. Fault tolerant, even if some data is missing or noisy, it still works well. Parallel processing, can deal with multiple tasks at the same time, just like our brain. 7. Challenges. But there are still some challenges. Making chips that are as big and complex as the human brain is tough. Building these systems is expensive and tricky. Plus, the software is still catching up with the hardware. 8. Neuromorphic computing versus AI. You might wonder, is this the same as AI? Not exactly. AI is software that learns and makes decisions. Neuromorphic computing is hardware designed to think like the brain. When combined, they can create super smart machines that can learn and adapt in real time. 9. The future. In the future, neuromorphic computing could power robots that learn by themselves, cars that make decisions in milliseconds, and even machines that think and reason more like humans. It's a huge step toward closing the gap between artificial intelligence and real intelligence. So, that's a simple introduction to neuromorphic computing, the future of smart and energy-efficient machines. If you found this video interesting, give it a thumbs up and subscribe to my channel for more cool tech videos. See you next time.